Hey friends, today we are going to talk about one more type of collision detection. If you've been following my collision detection series, then you've noticed that we've gone from easier to more and more complex algorithms. So today's type will be more complex than all of our previous videos. It will require some special math formulas, but that doesn't mean you need to have any special knowledge before watching this video. Except I do recommend you to watch the other videos in this series because it will help you build up the knowledge needed for this one. Today we're going to talk about two different types of collision detection: line to point and line to circle. I combined them into one video for two reasons. First, they look similar, and it might help to see the exact difference in the algorithms. And you'll see how different they are even though they look similar at first glance. And the second reason is that part of the first algorithm will be used in the second algorithm. There are many games where you would want to use this collision detection type, for example, where the obstacles are line segment shaped. Okay, let's start with line to point. Let's take a look at this picture. The first thing that comes to my mind is that we need to calculate the point and the point in the line segment. And if it is 0, collision is detected. So the steps would be: identify the point on our line, then draw a perpendicular line through our point and the point on the line, then measure the distance. Based on the result, make a decision whether collision happens or not. Honestly, it doesn't seem super simple. So is there an easier way? And the answer is yes. Let me show you a more efficient method that I found for this type of collision detection. Look at this picture again. If you measure the distance from the beginning of the line to the point and the distance from the end of the line to the point, you might notice something interesting. As you can see, we have one very specific case. It doesn't matter where our point touches the line, but if it happens, the sum of these distances are equal to the length of the line. This is exactly what we are going to use for our collision detection algorithm, point to line. No other complex mathematical calculations, only this trick. Okay, let's get started with our coding to show how it works. First, let's just draw on the screen a line segment and a point. But instead of a point, let's draw a small circle just to see it better on the screen, because the point will be very small. Let's add one more variable to our program, and let's call it accuracy. By assigning and changing this variable, we'll change how accurate our collision will be detected. In my previous videos, I always used separate functions to move objects around by using keyboard keys. Now let's use a simpler method and make our point follow the mouse. It is simple to do with Love2D mouse functions. Now let's create an empty collision detection function, line to point. And if collision is detected, let's change the line and point size and color. If you have any difficulties with measuring the distance between 2 points by using their coordinates, I recommend you to check this Love2D General Math Wiki page because it has many helpful functions. And we need this one. Let's just copy and paste it. It's actually implemented with the Pythagorean theorem. We talked about it in my previous videos, so now let's just use it. Okay, let's test it. Great, seems like it all works. Let's change our accuracy variable to detect it early. Okay, great. That's pretty simple, right? I think this is much better and simpler than any other approach. Now, let's look at another scenario where instead of a point, we have a circle. At first glance, you might think, okay, this is the same. All I need to do is adjust the accuracy. Maybe. Let's try to do it and see if it's going to work. First, let's make some changes to our demo program. Let's change our point and make it a circle. It is actually a circle right now, but I'm going to make it bigger so we will see the difference better. Let's adjust our accuracy. And let's also change the circle mode to line instead of fill. Okay, let's run our program now. Let's test it from different sides. Seems like it works, right? but let's move it to the end or to the beginning of our line. Wait a minute, I want to detect my collision here. But you see, our program is not doing a good job here, and we need something else for the case with the circle instead of a point. Since our problem zones that we identified so far are the line's ends, let's start from here and change our collision detection function to properly detect collision around the line ends first. The first part of our algorithm will be to calculate if our circle has an intersection with any of these 2 points at the beginning of the line or at the end of the line. We are going to use, for this purpose, a very familiar collision detection algorithm, point to circle. If you don't know how it works or you want to remind it to yourself, please check my video, Collision Detection Guide, Point to Circle. It is simple and very helpful. Here, I don't want to spend time by explaining it again and again. I'm just going to use it. Okay, you see our program now correctly detects collision on these line segments. Let's get back to our program and change the circle line mode back to fill since we see it works fine at the line ends. And let's make the circle even bigger. Now it's time to move to the more complex part. Let's look at this picture. We clearly see that we want to check this distance, and if it is less than the circle radius, then we can say that collision is detected. And here is the first challenge: how to identify the coordinates of this point. This point will be different, and all the time our circle is moving around. Here we are going to use this math function. The function is a little complex, and I honestly don't clearly understand this vectors concept yet, so we're just going to use it. You can memorize it or write it somewhere, or save my video to your playlist so you can later reference to it if you need to. So here are the steps of how to find the closest point from our circle to the line. First, we need to find the dot product of the two vectors, where our vectors are our lines, from the circle to the end of the lines. For this purpose, we also need to calculate line length. Okay, now let's use these formulas to find the coordinates of the closest point on our line and draw a circle with these coordinates on the line so we can see that it actually works.
Okay, great, it works. By the way, our collision on the line ends is working too. So to finish it up, all we have to do is calculate the distance between the circle center and the closest point and compare it with our radius, right? But first, we have to fix this function. As you remember, since we moved from point to line to circle to line algorithm, I changed all point-related variables and function names to circle. But this specific function is still the point to circle algorithm. So let's change it back now, but it will remain here. We're not going to delete it yet. Also, let's move all this circle to line collision detection logic to a separate function. Once we moved it, we need to call this function from the love.update game loop function. Okay, great. Looks like it works perfectly. But let's move our circle over there. You see, our collision is still detected, but of course, since we don't have the line here, we should not detect collision. So we need one more check, and for this check, we are going to use our previous function that we created for the collision detection point to line. You see, that's why I told you not to delete it. So we simply want to check if our closest point is on the line segment or not. But here, I need to modify my point to line function a little since it accepts as an argument point table. But we don't have the point table for our closest point, so let's change it a little. Also, since this function became more complex, I want to make it more readable and more clean. Instead of using all these if-else statements, I just want to use return instead. If you don't know how return works, here's a very short explanation. Once your function sees the return statement, it will just return what you are asking to return and don't go to the next line, until it will be called again, of course. You also don't need to draw this closest point on our line anymore, so go ahead and just delete it.
Okay guys, that's it. You saw that our collision detection works well. And we just mastered 2 more collision detection algorithms. Okay, good luck with your game development and programming. See you in my next video, and don't forget to subscribe to Zakiak if you haven't already.